Share my screen. Just hold on. Um, okay, show my screen. Let me put my camera. Okay, I hope y'all can hear me properly. Before we start, I want to see, does anyone has any question based on everything we did yesterday? Any question? Oh, okay. Okay, since there's no question, I have a question for you guys. What is the key takeaway that you took from yesterday? What is the key takeaway that you took from yesterday? So if you want to answer, you can raise your hand. Anyone? It can even be one thing that you learned yesterday. Okay. I'll just go back because today we have some new people. So I'm just gonna run in what we did yesterday. So yesterday we had our first session, and it was the introduction to blockchain. And this is what we learned. So we covered what is blockchain and the history and evolution, how it works, and the core concepts. So we are around here. We're learning about smart contract, consensus, and why it matters. And today we also gonna go through the overview of different blockchains and blockchain in action. So here, for those who didn't make it yesterday, I made some recording, so you don't have to worry. So we can go through it, talk about the evolution of blockchain, and then how it works. We talk about the block structure and transactions, and also promise I'm gonna show you how hashing in action, how it works for you to better understand how it works. And we talk about the most important terminology in blockchain, then about smart contract, self-executing contract, with the terms directly written into code. And we spoke about the wallet, the node, ledger, consensus, hash. And we spoke about decentralization, the consensus mechanism. This is also something very important that you need to know, all the type of different mechanism, the consensus mechanism, and the benefits of blockchain, and the use cases, some of the use cases, like in cryptocurrency, supply chain management, healthcare, finance, and voting. Voting is something that I think you need to start implementing in the government. So this is where we left off yesterday, the overview of major blockchain platforms. I know we'll focus a lot on Stellar, but we don't have to. It's also good that you also learn of other different blockchains, because there's hundreds of them, like Bitcoin, which is the first and the most well-known cryptocurrency, and it primarily used as a digital gold or storage of fund storage. There's also Ethereum. Ethereum is a decentralized platform that runs smart contracts and decentralized applications. And then Stellar, with Stellar 2, Stellar also runs smart contracts, but they focus primarily in cross-border payments and remittances. And there's also Hyperledger, which is an open source collaborative effort to advance cross-industry blockchain technology. And then there's also Cardano, which focus on sustainability and scalability. We'll go a little bit deeper into that. Bitcoin. So Bitcoin was the first and the most popular blockchain platform. And it has its cryptocurrency called Bitcoin. It's a decentralized digital currency that operates without any central authority. There's nobody that can switch off Bitcoin because it runs on thousands or maybe millions of different nodes all around the world. So if you decide to destroy maybe half or maybe 50,000, or maybe even if there's only 2 nodes remaining or 2 nodes that runs Bitcoin, you're still going to have all the transactions, all the valid transactions. So this what helps. So there's no single point of failure in blockchain. So the use cases of Bitcoin, it's digital payment, and like I said, it's store of value. It's also known as a digital gold. Another crypto blockchain platform is Ethereum. So Ethereum is a decentralized platform that enables developers to build and deploy smart contracts and decentralized applications. Some of the key features, it uses a Turing-complete programming language, so you can actually have your idea and put it to life and code it on the Ethereum blockchain platform. It supports the creation of custom tokens like ERC20 and NFTs. So NFTs were like very popular. I don't know if they're still popular. Non-fungible tokens. So basically, you can have a piece of art, a digital art, or maybe a video, and then you store it, use your smart contract, and then you store it on the blockchain with the proof that you own it on the blockchain. It's transitioned from proof of work to proof of stake, and this proof of stake was Ethereum 2.0 because with proof of work was very power intensive. So they were like, we don't want to destroy environment with this technology, so let's move on to something better. And that was proof of stake. The use cases, decentralized finance, non-fungible tokens, and decentralized autonomous organizations. You can do more research on that in your free time. Okay, so next up, we have Stellar. So Stellar is a blockchain platform designed to facilitate cross-border payments and asset transfer. The key features, it uses Stellar consensus protocol. So this is very different from the proof of work or proof of stake. And this protocol makes it fast, and it also enables low-cost transactions. They focus on financial inclusion and connecting financial institutions. So they're very active in that. They work with government, they work with financial institutions like MoneyGram, for example. So they've created a lot of partnership with different institutions, financial institutions. So they also support the issuance of custom tokens. The use cases, remittances, microtransactions, asset tokenization. Microtransaction is also something, it's also very important when it comes to financial inclusion, because when you use cryptocurrency such as Ethereum, and it tends to be sometimes when the network is congested, when the net is very busy, the transaction fees tends to be high. So for example, you want to send $100 to someone, or maybe you want to send $20 to someone, and it costs you $10 in transaction fees. And even today, like I had that problem. Uh I wanted to transfer my USDT. I wanted to transfer my USDT in my on the Tron chain. So it cost me almost $10 just to make a simple transaction. And it really it kind of pissed me off. So with Stellar is very good when it comes to microtransactions. So you can send as little as uh, $1 to someone and with minimal fees. So now here we're comparing some blockchain platforms. So there's Bitcoin, focuses on digital currency and store value. We have Ethereum, provides a platform for decentralized application and smart contracts. And then we have Stellar, which specializes in cross-border payments and financial services. Any question so far? So if you have any question, you can ask me. You can raise your hand. Okay, we're moving on. So we go back a little bit just to further solidify what you learned. So Bitcoin is the first and most well-known blockchain, designed primarily as a decentralized digital currency. Its main focus is on being a secure, censorship-resistant store of value and a medium of exchange without relying on central authorities. Bitcoin uses proof of work consensus mechanism, which ensured strong security, but limits transactions throughout and transaction throughput and energy efficiency. It specializes in simplicity and immutability over programmability, making it ideal for value transfer rather than complex application. And then there's Ethereum. Ethereum is a decentralized platform for building and running smart contracts and decentralized application. It introduced programmability through its Ethereum virtual machine, or also known as a EVM, allowing developers to create complex logic on chain. So the difference between Bitcoin and Ethereum is Bitcoin was just used for a store of value and doing transactions like sending value or sending crypto to someone else. So basically, it's a bank, a decentralized bank. But Ethereum came with a twist. It introduced programmability, so you can build application on top of the Ethereum platform. And so you can create applications like decentralized finance applications, non-fungible tokens, and you can even have an organization that is run in a decentralized manner, like the DAO, decentralized autonomous organizations. Though it started with proof of work, Ethereum now uses proof of stake for improved scalability and energy efficiency, and it continues to evolve with upgrades like sharding. Stellar is a blockchain focused on cross-border payments and financial inclusion, especially in emerging markets. It is optimized for fast, low-cost transactions using its native token, XLM, and supports issuing digital assets and stable coins. Stellar is designed to connect banks, payment systems, and users, enabling seamless asset transfers and integration with legacy finance. Its consensus protocol, the Stellar consensus protocol, is more lightweight than proof of work or proof of stake, allowing quicker finality and lower resource use. So Stellar focuses a lot in emerging markets because, like, one of the vision is to make payment as easy as sending an email, and also opening up making financial inclusion open to everyone, and especially in emerging market. So if you have an idea if like maybe you're from Kenya or from South Africa and you have an eye and you see gaps in your community, like in the financial market, if you can see some gaps, then you can use Stellar as your way to solve a problem. All right. Now that we're here, so some key concept recapped. We learn about consensus mechanism, decentralization, transparency, and immutability. So I'm going to ask, can someone here explain, like in your own word, explain what is consensus mechanism based on what you learned so far? Or if you want to, anyone can raise your hand. Because I don't wanna name names. Okay, Mukhtar, you can answer consensus mechanism. What you understand by it? You can unmute yourself.
Sorry about that. So it's basically just a voting mechanism. So users vote on what they want to do and how they want to do it.
Yep.
And that can either be used for mining, for changing protocols, for doing a whole bunch of stuff. Like if they want to add extra things or they want to swap to a different, encryption algorithm or do whatever, they can just use it.
Correct. Thank you, Mukhtar. And someone else, decentralization. Can someone explain what is decentralization? Before I call out names. Okay, Mohammed. Thank you, Mohammed.
Yes, decentralization, it means to distribute the control to many people or many organizations, not in one person or one organization. This prevent you from like signal failure.
Yeah.
And prevent censorship also.
True that. Yeah, thank you, Mohammed. And I want one person to explain transparency when it comes to blockchain. What is transparency? What do you understand by transparency? Anyone? Okay, excuse me. Just give me 1 second. I want to share. Someone want to join. Doesn't know where to find the link. But in the meantime, anybody? Transparency. What do you understand by transparency? Costa. Okay. Notemba. Transparency.
I think it simply means that the transactions are open to everyone, like there's no hidden agendas, if I can just put it like that.
So everybody can view your if all addresses on the blockchain. Yeah. The ledger basically is auditable to everyone. Thank you, Notemba. And last but not least, immutability. Anybody? Costa? Costa, do you want to try?
Hi, Ben. Just popping in now. Sorry, I was late. So I just
okay.
Yeah, so I'm not prepared yet.
Yeah, I'll jump into Bulela. Bulela,
Yeah.
can you try? Can you try to explain what you understand by immutability?
Okay, I believe it would mean that once the transactions are on the blockchains, they can't really be modified or altered. Yeah, I think that's my understanding.
Yeah, thank you. Very good. Thank you for everyone who answered. Now we're going to see blockchain in action. So yeah, this is if you're in the blockchain space, you've heard of Alice and Bob. Yeah, sorry about that. If you've heard it a lot. So this is the transaction example. Alice sends 1 Bitcoin to Bob. So once Alice sends that 1 Bitcoin, the transaction is broadcasted to the network. Then after it's broadcasted to the network, the block is added to the blockchain and the transaction is confirmed. And the miners validate the transaction and add it to a new block. I'm not show you how it works. This is just a brief overview. And here is a diagram of the blockchain transaction flow. You have a transaction that is requested, authenticated, and a block. Then a block is represents created transactions, and then it's then broadcast to network. So the network are all the nodes, all the computers in the system, and then all the nodes validate the transactions, and the node then receive a reward to validate in crypto. Then the block is added to the existing chain, and once it's added to existing chain, the update will be shared across the network. So all copies of the blockchain in every computers in the network will have an updated chain, and then the transaction is complete. Okay, this is the future of blockchain technology. So these are some of the innovations that has been going on. So there's been increases in security by reducing single point of failure. There's been scalability solutions. So there's more and more people join the network. It's some blockchains were just getting more expensive. Like Ethereum, for example, to send a transaction could cost $20, $30 just to send a transaction. And also one day, I was also into trading and buying new crypto. So there was a specific day I tried to buy a crypto called, I forgot the name. I forgot it, ApeCoin. Yes, I don't know if you've heard of it. So when ApeCoin just dropped in, I wanted to be one of the first people to buy that coin, and it was in the Ethereum chain. And because there was a lot of congestion, I didn't want to put a limit to how much gas fees I want to use. I was ready to use any gas fees. So by the time I bought that coin, by the time I was just about to buy ApeCoin, unfortunately, the transaction did not go through, but I lost almost $100, in failed transaction fee, and I was so mad. But this is something that could happen, but there's layer 2 solutions, like in Ethereum itself. They have some layer 2 solutions that like Polygon, Matic, that make it much more cheaper. There also has been increased privacy features like zero knowledge proofs, which I'm gonna send you the link to read more about that. There's also been integration with emerging technology like Internet of Things and artificial intelligence. So some of the adoption trends, there's increasing use in finance. So a lot of banks, financial institutions are adopting it. While back in the days, they used to think it was a scam. Most financial institutions did not believe that cryptocurrency will be as big as it is right now. So they thought it was a passing phase, not taking it seriously. But now government, financial institutions, banks are entering the space. And it's also used in supply chain and also healthcare. So there's growing interest in decentralized finance. I wouldn't say NFTs, but NFTs used to be popular a few years back, but maybe in the near future, because now with AI, you can basically copy. You can take someone's face and create a video using some people's face or using an actor likeness. So maybe in the future, NFTs will be implemented to solve that problem
Okay.
of people using likeness.
Hey, Pastor.
Costa, are you asking any question?
Sorry. No question. Sorry.
Oh, okay, no. And there's also regulatory development and standardization. So many countries are working with to create. They're trying to find ways to regulate cryptocurrency. South Africa, for example, and the US, Europe. So they've been saying that crypto it's not something that we have to ignore. Cryptocurrency and blockchain is something that does not have to be ignored. And yeah, this is it for now. But as promised, I want to show you blockchain in action to further solidify how it works. So yesterday this is where we were. Let me just go back just to kind of refresh your mind. So yesterday we just had an overview of how blockchain works. So you think of each block as, we use the analogy of a record book. So you think of each block as a page in the record book. It holds transactions details and a unique code. A unique code. Where did I go? Sorry about that. And the unique code. So this unique code is like a digital fingerprint of all of the combination of the block number and the transaction. So this code is linked to the code of the previous block, creating a chain. And the block structure has the header and the transaction. So the header contains metadata such as the previous block hash, the time spent, and the nonce. We'll talk more about the nonce. And then there's the transactions, which is a list of all transactions included in the block. And then data storage and linking. Each block references the hash of the previous block, forming a chain, which ensure that altering a single block will require altering all subsequent blocks, making tampering difficult. So let's see it in action. So this is just a demo of how blockchain works. So we'll start by the basics. So we want to understand what is a hash. So this is a hash, and you can see it, whatever right here, it's fixed length. So a hash is just a digital fingerprint of any data that I put here. So I can write my name, type my name, for example, and you'll see like it starts with 030. So if I just make a small change, like I put an I at the end, it will change completely. So any slight change created very different hash. So there's no way of you even predicting, there's no way of you taking the hash to try to find this information. But if I write Ben here, you see like Ben with lowercase, it starts with 670, and I erase it. I write that again, 670. So whatever, so the hash doesn't change. So the specific value, every value or the data that is here, every data that you put here has a specific hash, so a specific fingerprint, and the length, it has a specific length that doesn't change with whatever data that I put. I can put anything. It can be a video, it can be a picture, any data basically, and it's going to be a fixed length. So does everyone understand the concept, this concept so far? You can put a thumbs up if you understand.
It's encryption, Ben.
Yes, you take encryption. So
Okay.
so this is just, yeah, I'll say just a, we'll go further to further explain like how it works in the blockchain, but it's just an explanation of how this encryption, this specific encryption works. So it's one way. So you can decode this hash. Does it make sense? You cannot decode it to find what is the data because it's a one-way hash, and it has a maximum length that does not change. So whatever data I put here is going to be a fixed length. So from here now we're going to move on to blocks. Okay. So this is a block, and we can see here's the number 1. So this is the first block, and here we see a nonce, and here is the data. The data here is empty. So even the empty as in hash. So this is basically the hash of the empty. So I can mine it here. You find the same. Nothing's going to change. And does anyone here knows what is a nonce? Anyone knows what is a nonce? So a nonce, okay, a way to explain a nonce is okay, let me give it this way. So if I write 1, you see that this block is wrong, because according to the algorithm behind this blockchain that I'm creating, and it has to start with a specific amount of 0. In this case, it should start with 3 zeros. So that's essentially like the proof of work in this system. So I have a specific data. Maybe I have like let me see, Ben, for example. So Ben is the data, and we have a block. The block number is number 1, and then we have the hash. So now we want to mine this information and add it to the block. So how does the mining itself work? So so that's where the nonce comes in. So there's going to be this computer that is running this this node that is running this block will now generate random numbers until it finds a number that, with combination of the data and the block, it must generate a hash that starts with 3 zeros. So this is basically the proof of work that is happening. So now when we talk about different nodes in the system, in the network, the first computer to find the correct nonce is the one that's going to receive the reward. So let's say, okay, if I mine it here, you want to see it in action. Okay, I mine, and then it's going to generate a nonce. So it's still looking. Then there's going to be another computer also that is doing the same and trying to find the nonce where, in combination with the data, the nonce itself, and the block number, it must generate an hash that starts with 4 zeros. So in this case, that nonce is 72782. So that's the nonce. So now we've seen proof of work in action. So let's make a change. Let's say I write Costa here. So since I write Costa, the data has changed. The nonce is still the same, and then the block is still the same. But the hash, remember, the hash is a combination. It's a combination of the block the combination of the nonce and the data. So all this combination forms a specific hash. And this is a specific hash which starts with 3FB1. But this hash is not correct because according to the algorithm, it has to start with 40 to become a valid block. Does it make sense? So I have to mine it again, and then it's going to find a nonce. So in this case, the nonce is 976. And this hash means that we have a combination of the block, the nonce, and the data, and then it's formed. And then last example, I'm going to write Bulela. So the nonce is still the same. You can see now the hash changed. So now I have to find a new nonce where in combination with the data and the block, it must generate a new hash that starts with 4 zeros. So now there's going to be other computers, other nodes in the network that are gonna try to do the same. So whoever gonna find it first, whoever gonna find the nonce first is going to get the reward. So this is where the mining is happening, mining in action. We wait. Okay, so this is the nonce. Does it make sense? Does it make sense so far?
Yes.
If you understand,
Yes.
thumbs up.
Can you repeat it, yeah, Ben? The nonce, what's
Okay,
so
so
important of the nonce?
okay, to repeat, a nonce is a random number that is generated by, if you're talking about your computers, so we say, okay, your node generates the nonce. The miners are generating the nonce. So let's say I put some data here, like Ben, for example. You'll see that the hash starts with 9BF40, and we haven't generated the nonce yet. And okay, here the nonce is 93453, but it's not, when you combine it with the block number and the nonce itself, it gives this hash. But we want to mine it, we want to add this information in the blockchain. So what happens now is we have to, the miner has to find a specific number that when combined with the data and the block number, it must generate a hash that starts with 40. So this is our block difficulty. I don't know if you've heard of block difficulty. So this is our block difficulty. Our block difficulty is our hash should start with 40 for it to be a valid block in the blockchain. So now we don't have a nonce. We have the previous nonce for the previous data that we had. So when we mine, our miner basically is going to search like 1, 2, is going to go through numbers like 1, 2, 3, 4, 5, 6, 7. So the fastest miner will be the one who's going to receive the reward. So when I mine, so it's basically looking for a number. I'm looking for a nonce. Where when combined with all this, so okay, so this is the nonce that we find. So 31648 is our nonce. So basically this hash here is the combination of the block, the nonce, and the data. Just like we did it, just like we saw here. Here, our hash was just a combination of anything that we type. It was only anything that we type here. So only the data. Our hash was only the data in this specific case. But here, our hash, sorry, here, I think I did the wrong thing here. I was saying our hash is whatever data that we put here is generated using the data that we put here. In the case of a block, our hash is a combination of our block number, our nonce, and our data. But for the block to be valid, it has, according to the algorithm of the block difficulty, it has to start with 40. So now when I put, like for example, J, let me write J here. When I put this is my data, J for example. Then for this hash, for this block to be valid, the hash has to start with 4 zeros. So now I'm gonna be generating different nonce, like from 1, 2, 3, 4, 5, 6, 7, however. And then the faster I get to that, the better. That's when I'm gonna get my reward. So a mine, you know, here it's taking longer. So probably the number is gonna be long. So it's searching for a number that when combined with the remaining number, it should have a hash that starts with 4 zeros. And you can see this is a bigger number, and it took long because it was like from 1, 2, 3, 4, 5, 6, 7. So it's testing out all the numbers until it finds a number. When combined with all these data, the combination of the block number and data, and then it finds the hash. Does it make sense now?
Yes, makes sense now. Thank you.
Okay, now that we understand block, now we move into understanding the blockchain. So as you can see here, there's a chain of 1, 2, 3, 4, 5. So there's a chain of 5 blocks. And here you're going to notice that here in the first block, you see previous. Previous is 0, 0, 0, 0, 0. And you can see a nonce. So this hash is a combination of the block number, the nonce, and there's empty data here. And then you go to the end, you will see that there is previous and there is hash. So for the sake of not wasting time, let me just go through it a bit quicker. You see this previous hash is the hash of block number 4. Can you see that? Thumbs up. Previous hash is the hash of the 4th block, right? So, and this goes on and on. So block 4 has previous hash from the hash of the 3rd block, and so on and so forth. So this is a pattern. But then since this is the first block, and the first block is also known as the genesis block. The genesis block has a previous hash of 0, 0, 0 because there's no block that are ahead of it. So that's why the previous hash here is 0. And then this hash is just a combination of all these values like block, nonce, and data, and the previous hash. So unlike the block, unlike what we saw here we did not have previous hash. So it was just the data, a combination of block number, nonce, and data. This time we have block, nonce, data, and previous hash. So this makes it very difficult, even more difficult to mutate data. I'm not show you in action. So let's say over here, I decide to change the data. If I put, let me write A, for example. So if I write A, this hash is going to change. Can you see, right? The hash change. The previous hash is still the same because I'm reading from the previous block. So the previous hash is correct. The nonce is not correct. I'm in the 4th block, and the hash, the new hash, is wrong. And then that's also going to affect the following block because, okay, this hash also doesn't start with 4 zeros because the previous hash that messed up the whole thing, right? So let's say if I mine, okay, question to you, what happens if I mine here? What if I mine here and then I get the correct nonce? What's going to happen to this? Anybody want to answer? What if I mine here? So because when I mine, remember when I mine, the nonce is going to here look for the specific number that when combined with all all this information that I have here, there is going to generate a hash that starts with 40. So what happens to the next block if I do that? Because in principle, if I mine, then it's going to be valid, right? Because if I mine this one, then it's going to find the correct nonce, then it's going to have the correct hash, right? But then what happens to
Yes.
the block?
Will be still not valid.
Sorry?
The next block will be not valid.
Yes, true. Because once we do that, okay, see it in action. See it in cache. So when we do this, when we mine here, it's going to generate a new hash that starts with 4 zeros, correct? But then that hash will go, oh no. So, okay. Now we've mined, you can see that we've generated a new hash. So this new hash is going to be this block's new previous hash. But still remember that everything has to make sense. So the block, the nonce, and the data, and the previous hash must create, because remember it's unique, it must create a hash that starts with 4 zeros. So now we have a different nonce, we have a different previous hash. So it's not going to work. So we can do the same for the sake of saving time. I'll put the link. I'm going to share this link for you to play around with it. But if I do the same here, the whole chain is going to be invalid. Let me just show it quickly. If I do the same here in the second block and I mine, so the second block is going to be valid because I'm going to have the correct nonce and the correct hash that start with 4 zeros. But the next ones are just going to be wrong because I'm going to have a new previous hash that's going to mess up the whole, that's going to give it a new hash here, over here, that does not start with 4 zeros, and so on and so forth. Does it kind of make sense? Do you get the idea behind a little bit? You know, you see the vision on how blockchain works?
Yes. That means you can't change something you add, right, in the
Yes.
blockchain.
Because once you change, you mess up everything. So now,
Yes.
now we have a block, but here we're just dealing with a blockchain ran by one node. So this was the node trying to make some changes. Like, let's say I'm running a node and I want to make changes. This was me doing that. So it's not broadcasting to the whole network or anything. But even when I'm running on my own, if I make one change here, it's going to mess up the whole chain. So now we're moving to the next step. Now we're going distributed. Now it's not only one node that is running the whole blockchain. Now we have peer A. So peer is also known as like a node or a computer. So we have peer A, we have peer B, peer C. Yeah, we have peer up to peer C. So we have 3 nodes in the network. And something that you should also notice is they have an identical blockchain. So they have a copy of the blockchain. So what you see here, you're going to see down here. So they're exactly the same. Meaning that all the transactions was broadcasted to other nodes in the network, and they all had similar copy. So now let's say I'm a bad actor. I'm running a node and I want to modify some transactions. So I go here and then I make some changes because I'm like, okay, if I make some changes here, then the whole remaining of a chain is going to be invalid, right? Correct? If I make some changes here, as you know, like as we saw previously, the whole remaining of the chain is going to be invalid. But I'm like, okay, what about if I just modify the last one? Because I can still make a valid chain in my node, but it's not going to be valid throughout the network. Let me show you in action. So let me type something here. And you can see now I want to get the correct nonce. So I mine it. I'm mining my own node with modify data. I mine it. Let's wait. So in theory, it's supposed to get, I'm supposed to get a correct nonce and a valid hash, right? Does it make sense? Does it make sense? I'm going to get the correct nonce and a correct hash that start with 4 zeros. Is it confusing you or it makes sense? If it's confusing
Yes,
you,
makes sense.
thumbs up. If you're confused, thumbs up. Sorry about that. I think my network is tripping, taking so long to mine. Okay, correct. So I'm mined successfully. But remember, if I mine here, the whole thing here will have been wrong. But I was like, I'm gonna be mining because I'm trying to be smart. I'm like, okay, I'm gonna be mining the last block, and I'm going to pick. I'm going to put my own data. Maybe it's my own transactions. Maybe I'm gonna say, okay, I'm gonna lie that I actually, instead of send, I promised someone I'm gonna send him 50 Bitcoin, for example. I promised 50 Bitcoin, but I actually sent 10 Bitcoin. But then I want to make some modification to say, okay, I actually sent 50 Bitcoin. I sent 50 Bitcoin, so I want to make some modification in the node. So in my node, this will show, okay, but is it going to be accepted? It's not going to be accepted because once you look at other peers in the network, they're going to have different hash. They're going to have different hash because here you can see it starts 4 zeros and a 16, but here it's 4 zeros and a E4 here, and the last one here, it's 4 zeros and a E4. So immediately you see that there's a difference. It's not consistent, so it's not going to be accepted. And another reason why hashes are used is to make it very easy for you to find transactions and to also see that the transaction is valid. Because let's say we're not using a hash, then and you want to see that every transaction was actually valid, then you're gonna have to run a code that look through everything, like look through trying to find that everything is consistent, one block at a time, reading all the data, which is going to be very time consuming. But when we just create a hash, it makes things easy for you, because now the hash is just a proof that all this data that is here is consistent. Does it make sense? And we're going to go here, because remember, so far we haven't, the data is empty. There's no transactions, right? We didn't see our transaction. We didn't see transaction in action. So now we're going to see transaction in action. So still the same principle, the exact same principle what we learned so far. But here the only difference that we have here is we have transactions. We have a list of transactions. Like here, there's a transaction, $25 from Darcy to Bingley, $4.25 from Elizabeth to Jane. So this is what happens in the transactions that are stored in the blockchain. So every block has a list, or we call it a ledger, of transactions. So now, in this case, when we are mining, or when we're also trying to find a nonce, it takes the block number and it takes the nonce, it combines all of that with the transaction and the previous hash to create a new hash. That has to start with 5 zeros in this case. No, 4 zeros, sorry. It has to start with 4 0. So when we mine, we get this. If I make some changes here, then you'll see that it's going to be chaos, right? Any change of transaction, if I say, okay, I want to change the $6 to a $10, it's a disaster. It's ruined. So I'm So everyone understands so far like how it works in principle. So if I make any changes here, it's going to ruin the whole chain. But one thing about this is it's like money just came from thin air. We don't even know how much Darcy has. We don't know how much Bingley has. We don't know. We just say, okay, transaction 25 from Darcy to Bingley. So we want to go a little bit further to see how how it all starts. So this is Coinbase transactions. So we have the initial transaction is $100 came from whoever went to Anders. So here we assume Anders is an address, is a public address in the blockchain. So we sent $100 to this public address, and this is the previous hash this is the first block. So the first block recorded that there was funding that came from Coinbase to the following address, and it has these nonce and this previous hash. So now it creates this new hash. And now here, now things start making sense because we know that Anders is $100. And again, in this block number 2, there's also Anders now has another $100. So far, he has $2 in his pocket. And then here we see the transactions. We see $10 from Anders to Sophia, 20 from Anders to Lucas, and so on and so forth. So we see all this in action. We see like where the money is moving. So now we can actually trace all the transactions, where it came from. And if you go through this, I'm gonna give you the link. It's all consistent. The only time we'll say the fund is coming from thin air is this spot when you say, okay, Coinbase gave $100 to Anders, $100 to Anders here, and so on and so forth. So if I make some changes here, then I ruin the whole thing. So if, like, for example, the names here symbolizes the address. So if I just change something, then the whole chain is invalid, and so on and so forth. So yeah, I will end here. But anybody has a question? Any questions so far? Yes, Willa?
Oh, you said this class is recorded, right? Where do you post the recordings?
I'm gonna share a Telegram link, and I'll also share it on what you call it, on Discord in the South African chapter. Discord. Go to the South African chapter. I'm going to share it as well. So let
Where?
me. Sorry.
Discord.
Discord.
Discord?
Stella South Africa. Stella. Go to Stella Development Foundation Discord, and you go down to South Africa chapter. Are you in Discord?
Yes.
Or just go. I'll share it in the South African chapter. But I also created a Telegram group, so I'm going to share it now.
Okay. All right.
Paste it. Okay. Can you see it? So I just shared the Telegram group, so you can. This is where I'm going to share all my videos and the slides. So any other question? Any? Okay. So this marks the end of the first, the introduction to blockchain. So if you have any other question, I'm gonna be showing the slide today. So if you read something and then you have any other question, you're free to ask. And yeah, thank you for everyone for pitching in. I appreciate your engagement, and I hope to see you again next week. Same place, same time, same link, and yeah, have a wonderful evening.
You too. Thanks, Ben.
Thank you. Bye bye.
Cool.
Good night.
Bye. No.
Good
Bye,
night.
guys.
Thank you, Ben. Thank you so much.
Thank you. Let me Stop the recording here.